Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 2 from chapter 7, which is talking about absolute value functions. And in particular with this video, we're going to look at graphing the absolute value functions for a quadratic function. So below here we have two functions. We have f of x is equal to x squared minus 4 and f of x is equal to negative x squared plus 4. So just by looking at the graphs, can we tell what the graph of an absolute value function would look like? And so here, if you guys remember from last video, whenever we take the absolute value of a function, we reflect any of the negative y values. So anything that's above this x-axis here would stay exactly the same, but anything below would be reflected. So when we're just given the graph of the function, what we do is we just write down a few coordinates, and then we just change our y values to positive values. So in our first function here, we have negative, or this would be 0 and negative 4. And we might even want to write down just a few extra, just to make sure we have a nice clear picture of our graph. And so you want to try and find points that are very nice and easy to read. So maybe we have this point right here. This one here is at 1 and negative 3. And going along our other side as well here, we have this point right here. This one here is negative 1 and negative 3. So what we want to do with those points is that we want to make those y values positive. So this value right here, let's take negative 1 and negative 3, so that x value stays the same, but then we make our y value a positive value. So we're going to go up to negative 1, go all the way up to positive 3. Make a little mark there. Then we're going to go to our next one. We have 0 and negative 4. Well, that becomes 0 and positive 4. And then we have 1 and negative 3, so this should become 1 and positive 3. And then just remember that at this point, all of our values would reflect until we get to this x-axis here. And then at that point, everything would stay exactly the same. So what we should do is that we start at our x-axis, and then we trace our function. And so they should meet exactly at these x-intercepts, as after that point is where things start to switch. So if you notice here, what we kind of have is a shape of, it almost looks like a W shape here. This here is when our graph is going up. So now let's take a look at what happens if our graph is opening down. Let's see if it creates that same shape. So here, anything above the x-axis will be the same, so we're going to leave this part here, but then we have to consider these two parts down here. And so let's try and find a nice little marker to go with. So here's where we're going to be starting off, and then we're going to move down. Maybe we'll go to this point right here. So here's that your x is equal to. This one here is not as nice, but it's a little bit nicer than some of the others. So here you have, this would be negative 2.5 and negative 2. Here we got one value, then we do a value on the other side here as well, and it looks like it's about the same point here. So this would be positive 2.5 and negative 2. So let's try graphing those ones. So here we're going to be at negative 2.5, and this will become positive 2. And then we have 2.5 and positive 2. So you're always starting from that x-intercept, and then you're going to work your way up, passing through those points. So as you notice, it creates the exact same shape. So it doesn't matter if your quadratic formula is opening, or your quadratic function is opening up or down. You're going to get that exact same W shape. So here you're going to have a nice smooth curve at the top, and then a very sharp turn at your x-axis. So in this case, whenever we're graphing any quadratic functions, it's really important to know those x-intercepts. So now we're going to look at example number 1 from your notes, where we're going to graph a quadratic function. And in this case here, we're only going to look at graphing given the table of values, not by looking at the actual or the original function. So here we're going to consider the absolute value function, the absolute value of negative x squared plus 2x plus 8. And so in part A here, we're going to find the x and y intercepts. And just as a quick note, if your question didn't ask you to find your x-intercepts first, and it asked you just to go straight to graphing, you want to make sure you do this first. As we saw, it was kind of important because that's where our graphs start to reflect about that x-axis. So it'll be really important to find those points if you're not asked to already in the question. So the first one here is we can find out the y-intercept. So your y-intercept is where it crosses your y-axis. So that means that at that point, that's where x is equal to 0. So you're going to put x is equal to 0 into your equation, and then you're going to solve for y. So in our function here, we can replace the f of x with y, if that makes our brain happier. So you have y is equal to, so it's the absolute value of negative x squared, so negative 0 squared, plus 2 times 0, plus 8. So here we have negative 0 squared. So 0 squared is 0, and negative 0 is just 0. 2 times 0 is just 0, and then we have just 8. So 0 plus 0 plus 0 is 8, and the absolute value of 8 is just positive 8. So here your y-intercept, so scroll down here to slip it. So here your y-intercept is going to be at x is equal to 0 and y is equal to 8. Then we can do our x-intercepts, assuming that they assuming that they do exist. And so here, when we're looking at our x-intercepts, this here is where it's crossing that x-axis, meaning y is equal to 0. So in your equation, you're going to let y equal to 0 and you're going to solve. So you have 0 is equal to the absolute value of negative x squared plus 2x plus 8. And so just like we were talking about in our last video, when we're looking for, or when we set our I guess our left side of our equation equal to 0, when you're taking the absolute value of whatever this function is, we should be making this equal to 0. So the absolute value of 0 is just 0. So we can actually remove these absolute value symbols. So then from there, what we can do is now we have we have a trinomial here, so there's a couple different things that we can do. You can either factor this equation, or you can also use the quadratic formula. But in this case, it would just be easier to use the use factoring. And here we have an a value of -1. If you guys want to use our shortcut, all you have to do is move everything over to the other side. So here you want to add x squared, subtract 2x, and subtract 8. Because then what this does is that we make our a value just a positive 1, which we can use our shortcut for that reason. So we have x squared minus 2x minus 8 is equal to 0. As long as we do our math correctly, we will get the exact same answers for our x-intercepts. All right, so now we can go ahead and start to use our shortcut for factoring. So we have to look at our product and our sum. So our product here is your first and last term, so that's -8, and your sum is this middle term, which is -2. So you want to think of two numbers that multiply to -8, but have a sum of -2. So that means our numbers there are going to be -4 and +2. So then what we can do is we put two brackets here, set them equal to 0, and our variable goes on the left side. So we have x and x. Then our first number comes here, so we have -4. And then our other value here becomes +2, so that's an x plus 2. So from there we can set each of our factors equal to 0. So our first one here is x minus 4 is equal to 0. And we can do the same thing here as x plus 2 is equal to 0. And then we're just going to solve. So in our first factor here, we have x minus 4 is equal to 0. So we want to get rid of this -4, so we're going to add 4 to each side. And we find that x would be equal to +4. In our second equation here, or our second factor here, we want to get rid of plus 2, so we're going to subtract 2. And we get x is equal to negative 2. So what this here tells us is that we have our coordinates. So in our first factor, we'd have 4 and 0. And then we'd have negative 2 and 0 for our second factor there. So those are our x-intercepts. And that's going to be really important because that will help us see where our graph is reflecting. And we need to show where that reflection is on our graph. So those will be really important to put in for our table of values. And so right now I'm actually going to cut off this video just because I'm going to run over my time limit here on my free software. So I'm actually going to pick up part B of this question in the next video.